Welcome to our core Java tutorial for beginners, where you'll learn Java from the ground up. In this series, we'll start with the fundamentals, including variables, data types, and control structures. Each concept will be broken down with clear examples and hands-on exercises, making it easy for you to follow along and practice as you go. Let's dive in. Welcome to this tutorial on setting up the Java Development Kit, or JDK, which is essential for writing and running Java programs. First, visit the official Oracle website to download the JDK. Look for the download link that matches your operating system, whether it's Windows, Mac OS, or Linux. Once the download is complete, open the installer and follow the on-screen instructions. Make sure to note the installation directory, as you'll need this for configuring your system's environment variables. For Windows users, search for Environment Variables in the Start menu, then click on Edit the System Environment Variables. Under the System Properties window, find the Environment Variables button. Here, you'll need to create a new variable called Java Home and set its value to the JDK installation path. Finally, add the JDK's bin directory to the path variable. This allows you to run Java commands from any command prompt. With that, you're ready to start coding in Java. In this section, we're going to explore variables and data types in Java, which are fundamental concepts every beginner needs to understand. Let's start with variables. Think of a variable as a container that holds data. In Java, you need to declare a variable before you can use it. For example, if you want to store an integer value, you'd write something like int age. This tells Java you're creating a variable named age that will hold an integer value. Now, let's move on to data types. Java has several built-in data types, and they fall into two categories: primitive types and reference types. Primitive types include int for integers, double for floating point numbers, and char for characters, among others. Each type determines the kind of data it can hold and the operations you can perform. For instance, if you declare double price equals 19.99, you're now able to perform calculations related to prices, like adding discounts. So, understanding these basics is crucial, as they'll form the foundation of your coding journey in Java. Welcome back to our core Java tutorial for beginners. In this segment, we're diving into control flow using if-else statements and loops. Understanding control flow is essential because it makes your programs dynamic and responsive to different conditions. Let's start with the if-else statement. Imagine you want your program to check the weather. If it's sunny, you might print "let's go outside." If it's raining, you want to display "better stay indoors." In Java, that looks like this. You use the keyword if followed by a condition in parentheses and then a block of code in curly braces. If that condition is true, Java executes your code. Otherwise, it moves to the else block. Now, moving on to loops. Loops are great for running a block of code multiple times. For example, if you wanted to print numbers from 1 to 5, you could use a for loop. It's a compact way to repeat actions, making your code cleaner and easier to maintain. Stick around, and we'll show you how to implement these concepts with real examples. In this section, we'll dive into the heart of Java, classes and methods. To start, a class in Java is essentially a blueprint for creating objects. Think of it as a template that defines properties and behaviors. For example, if we have a class called car, it may have properties like color and model, as well as methods like drive and stop. Now, let's talk about methods. A method is a block of code that performs a specific task. In our car class, we might define a method called accelerate that increases the car's speed. Here's how it looks in code. We define the method with a name, followed by parentheses for parameters, and then curly braces for the code that runs when the method is called. This structure is crucial for organizing your code, allowing you to create reusable components. Now, let's see how to create a simple class and define methods in it. Get your code editor ready. In this section, we're diving into the core concepts of object-oriented programming, or OOP, which is fundamental to Java. First up, let's talk about objects. In Java, everything revolves around objects. An object is an instance of a class, which you can think of as a blueprint. For example, if you have a class called car, each specific car, like a red Honda or a blue Ford, is an object created from that class. Now, each object has properties, also known as attributes, which describe its characteristics. For the car class, these could include color, model, and year. Next, we have methods, which are functions that define behaviors of the object. So you could have methods like accelerate or brake that specify what actions a car can perform. Understanding these concepts is crucial, as they allow developers to create modular and reusable code, making programming in Java both efficient and intuitive. Let's move on to encapsulation, one of the key principles of OOP. In this section, we're going to dive into handling exceptions in Java, an essential part of robust programming. Exceptions are unexpected events that can disrupt the normal flow of execution. For instance, what happens if we try to read a file that doesn't exist? Instead of crashing our program, we want it to handle that error gracefully. In Java, we use try-catch blocks for this purpose. Let's start by looking at a simple example. We'll wrap our file-reading code inside a try block. If an exception occurs, like a file not found exception, our code will jump to the catch block, where we can handle the error appropriately, say by logging an error message or prompting the user. Another important concept is the finally block, which executes regardless of whether an exception occurred. It's a great place to close resources like file streams. By mastering exception handling, you'll create more reliable applications that can respond to issues without crashing. As we wrap up our core Java tutorial, let's quickly recap the key concepts we've covered. You've learned about Java syntax, data types, control structures, and object-oriented programming principles like inheritance and polymorphism. Remember, practice is crucial. Build small projects to reinforce these skills. Don't forget to explore the Java documentation for deeper insights. Thanks for joining and happy coding.